So, welcome back to the lecture series of communication system. In this lecture series, I am going to discuss about a frequency modulation, generation of frequency modulation, modulated signal. So basically, we have used the two methods we have used for frequency modulation. First is the direct method of frequency FM generation, and the second is indirect method of the frequency generation. So, what is the advantage of the direct method? First, it is a straightforward approach of the FM generation, and it require a voltage controlled oscillator. That's whose frequency oscillation has linear dependence on applied voltage. So once when we vary the applied voltage, that is the basically modulating signal or information signal, VCO output will vary. In this way, we are getting to obtain above FM output. So, and advantage here there is the large frequency deviation, and the disadvantage of this direct method is the carrier frequency tend to drift and must be stabilized. It means there are the drift in the carrier frequency signal. Generally, two types of circuit is used for direct FM generation. One is the reactance modulator and another one is the varactor diode. So again, just there are two methods, indirect method and direct method. In direct method, there are the two circuit that can be used. One is the reactance modulator and varactor modulator, and in indirect method, only one method is available, that is called Armstrong method of FM generation. So in direct FM method, instantaneous frequency of the carrier is changed directly in proportional to the message signal. So here basically Fi equal to Fc plus Kf into Mt, where Mt is the message signal, Kf is a constant, and Fc is carrier frequency, and Fi is the instantaneous frequency. So it is very clear that instantaneous frequency actually depends upon Mt, considering Kf is a constant, and Fc is a carrier frequency, which can also be a constant. So, and a detail of this about this particular equation is discussed in the previous lecture, and the fundamental of AM and the basics of AM. Then, then we discuss what is the reactance modulator. See this particular diagram. Here we are using a L and C. So basically, this particular L and C is form of oscillator circuit. It means it is a tank circuit or it is a oscillator circuit. So it means this particular circuit is resonated at a particular frequency. Then we have used a variable reactance. With the help of this variable reactance, we can vary the frequency of this oscillator circuit, and this variable reactance of this circuit is where depends upon the modulating signal. It means the amplitude of the modulating signal decide what is the reactance of this circuit, and this particular reactance decide the frequency of oscillation. It means its frequency of oscillation is proportional to the magnitude of the input signal. That is basically the method of FM generation. So if L and C of a tuned circuit of an oscillator is changed in proportional with the amplitude of the modulating signal, then FM can be obtained. Because here how we change the L and C just by the varying, and this variation of the reactance, and this variation of the reactance is proportional to the voltage, and this particular voltage is actually proportional to the information signal. So that is the that's all about reactance modulator circuit. Then the second method of direct FM generation is called the varactor diode modulator. So basically, varactor diode is a semiconductor diode with junction capacitance varies linearly with the applied voltage. So see this particular circuit. This particular circuit have a L and C circuit. Then we have a C and then a varactor diode, and this capacitance of this particular varactor diode is depends upon the applied voltage, that is already explained. So once we have applied this modulated signal is applied, we are use the we use a capacitor, and our FC choke, basically this particular circuit component is used for the blocking of the DC signal. So this modulating signal is appear at this time at the input of this varactor diode, and this junction capacitance of the varactor diode will change. Once the junction capacitance will change, then the frequency of oscillation of this whole circuit will change, and this frequency of oscillation is actually depends upon the modulating signal. So that is the basic philosophy how a varactor diode is used for the generation of a direct FM signal. Then the advantage of this type of the varactor diode and varactor diode method and reactance modulator method is first the simplicity and the low cost. But the advantage is the frequency of oscillation is not the constant. It means the oscillator is not stable. So its frequency of oscillation will change. So it create the problem in our output. Second, in this method we get a distorted FM due to the non-linearity of the varactor diode. So that these are the basically two disadvantages. One is the oscillation frequency that that must be constant, which we are not able to maintain in this particular circuit. And second, if you use the varactor diode, so varactor diode is a non-linear characteristics, and after a certain voltage is so a non-linear variation, it means we have not full control on output FM signal generated by this varactor diode circuit. So these are the disadvantage of the direct method of the frequency generation. Then we move to the indirect method of the frequency generation. In this indirect method, basically we use the two principles which can be combined to generate indirect method, indirect FM, and that is also called a wideband FM. First is the heterodyne method, and second is the multiplication method. And this particular method is generated by designed by a particular scientist that is called Armstrong. So it is also called Armstrong modulator. See this particular circuit. If we see this particular circuit, so here we use the two principles. One is the heterodyne method and another is the multiplication method. So see here, first we use a balance modulator. Then there are the pre-emphasis and frequency correcting circuit where we apply input signal, and then we use the crystal oscillator and a phase shifter. After this, we have connected to the RF amplifier. See here, this particular RF amplifier generates a narrow band FM, which frequency is centered around the 4 kilohertz, and frequency deviation is 14.17. Then we pass this output. It is basically a narrow band FM. This output is passed through a frequency multiplier, and then its frequency is multiplied around 81 times, and so the carrier frequency becomes 32.4 megahertz, and similarly the deviation become 1.172 hertz. So here see, it means this particular frequency is translated to the high frequency. Then again it passes through a heterodyne mixer, and this in heterodyne mixer we use a RF power amplifier and a frequency multiplier. This again we generate a frequency that around 90.1 megahertz. Then with the help of frequency multiplier we convert this frequency to 90.2 megahertz. But here and the deviation is around then its output is passes through a heterodyne mixer. Again we need to up convert this frequency. Then this up convert, before the up conversion, here in heterodyne mixer it passed through a oscillator signal. So in heterodyne mixer, our output of the frequency multiplier and output of the oscillator will mix, and it generates sum and difference frequency. So if you see that, we can select the difference frequency. So if we select only the difference frequency, it's around 1.41 megahertz, and the deviation is around 1.172 hertz. Then it's again passed through a frequency multiplier that multiply this center frequency into 64. So it's become 90.2 megahertz, and frequency deviation is 75 kilohertz. Then it's passed to the RF power amplifier, and then it's the passed to the out. So here actually what we can do, we can convert narrow band FM to a wide band FM just by using a frequency multiplier and heterodyne circuit. So first we multiply the frequency, then we pass to the heterodyne. In heterodyne mixer, we select a difference frequency and ignore the some frequency. So difference is 1.14 megahertz. So see here, we start around 400 kilowatt and we convert into 1 megahertz. Then again we multiply and we convert it to around the 90 megahertz. That is the used for FM transmitter. FM band is started around the 90 megahertz. So we convert it to the 90 megahertz, and the deviation is required for FM transmission is 75 kilowatt. So deviation is also converted into the 75 kilowatt, and then it is passes through the antenna. So before go to the antenna, we required an amplifier. So first it passed through the amplifier and then it's out. See here the small block diagram. Initially we have the signal having 400 megahertz and frequency 14.17. Sorry, deviation 14.47. Then we get multiplied to the 81 times and it becomes 32.4 megahertz and deviation become 1.172 kilohertz. Then it's passed through a mixer and we select a difference frequency. So again this frequency is down converted to 1.41 megahertz, but deviation is around 1.172. It means we maintain this deviation. Then we again it passed through a frequency multiplier and convert it into 90.2 megahertz and deviation around 75 kilohertz. That is our required deviation that we use for the modulation of the signal. So that's is about FM signal. Here we see the explanation, and just read this explanation. A complete Armstrong modulator is supposed to provide a kilohertz 75 kilohertz frequency deviation. It's use a balanced modulator and 90-degree phase shifter to phase modulate a crystal oscillator. Required deviation is obtained by the combination of multiplier and mixing. Raise the signal from the low frequency to a suitable for broadcasting. So these all about explanation given to, and basically FM transmission is start around 90 megahertz. That's why we convert this lower frequency into around 90 megahertz. And the second is we take the samples, voice sample. It means we have a voice sample that is around the 400 hertz, and we convert it 400 kilohertz, and we convert it into the 92 megahertz. It means we modulate the frequency. So that's all about the Armstrong method. Then if we summary, direct FM generation carrier frequency is directly varied by the input signal. Frequency drifting is a problem and frequency deviation is around 5 kilohertz. Indirect, it uses the non-linear circuit. It can use mixer to change frequency, carrier frequency. Combination of the mixer and multiplier provide flexibility. It is more flexible. Then if we compare our AM and FM, so SNR is increased without increasing transmitted power. So here in the case of FM, we can got around 25 dB higher SNR in comparison to the AM. So interference at the receiver are more easily to suppress. In the case of FM signal, interference is easily avoided in comparison to the AM, because the FM receiver has limiter which eliminates the amplitude variation and fluctuation. Third, modulation process can take place at low level power stage in the transmitter, thus low modulating power is required, and power content is constant and fixed, so there is no waste of power, transmitted power. And there are the guard band in FM system allocated by standardization body which can reduce the interference between the adjacent channel. So that is all about the application of the AM signal. So in this lecture we discuss about the generation of FM and all the two method, indirect method of FM generation and direct method, and at the end of this lecture we discuss about the application of FM signal. So thanks for your attention.